So hello viewers and welcome back to another video on layer 3 of networking. So in today's video we are going to deep dive into how OSPF works behind the scenes. We'll see the working of OSPF. So without wasting much time, let's get started. So this is the usual content of any of the protocol, any of the routing protocol that we will see or we are going to see on this channel. So in the previous video we have seen the introduction, what is the link state, OSPF history, we have seen the packet formats. So now this is the time to view the overview and how the OSPF is working behind the scenes. And in the next video we are going to see a demo of how we can configure the OSPF inside the Cisco packet tracer. So before we start the overview and how the OSPF works, let's just revise the content so we can have a clear idea that what we have seen till now. So we have seen the introduction, then we have seen what is the meaning of link state. So basically link state is just the protocol or the algorithm which is used to calculate the best part. Then we have seen the what is the main difference between the link state distance vector and the pure distance vector that we have seen. We have also compared the RIP and the link state distance vector protocol working in the OSPF. Then we have also seen the OSPF history, where we have seen the version 1, all the information regarding the RFCs and what are the major changes that has happened in the OSPF. Then we have seen the packet formats. So these are the main packet formats for the OSPF. Then these are the LSAs. So LSAs are nothing but the advertisement of the let's say any routes, and the routes and those have some types. So these are the types that we have discussed. Then we have seen the packet formats, the detailed packet format. So this is the hello packet format, then database description, then this is link state request LSR, this is link state update LSU, and this is link state acknowledgement LSAC. Now this is the today's topic, which is working of OSPF. So let's start with this. And if you want a brief overview, so I have already made the videos for whatever we have seen till now. So I highly suggest, if you are new to this video or new to this channel, before you start diving with the working of OSPF, if you are not clear with the OSPF, so you can watch the previous videos. So now let's start with the working of OSPF. So when we usually learn the OSPF, we start by the need of area, or what is the concept of area which is used in the OSPF. So as we have seen the link state algorithm, it learns the entire network topology that we have seen, and we have also compared the RIP with the OSPF, that how they differs, and we have seen that link state algorithm learns the entire topology. So let's say we can consider this as, let's say if there is one router, so it knows the full map of the network. So each and every router will know the full map of the network if there is an assumption that all the routers are learning or are running OSPF. Then it calculates the shortest path to every other router using the algorithm like Dijkstra algorithm. So that's the second thing. So this it does for all the routers that are there on the network. And now assume, let's say on the internet all the routers are there, which all of those routers are using OSPF. So let's say internet is so big, and if all the routers are running OSPF, they'll store all the like information regarding all the routes inside the router. So it will be more what you can say overwhelming for the routers. So to avoid that, what OSPF does is OSPF creates the area. So that's the third point. So if the large OSPF networks, so if the OSPF network is large, it can overwhelm the routers with too many link state acknowledgement, link state advertisements, and frequent recalculations. So to avoid that, we divide the networks in logical groups, and that logical group is nothing but the areas. So this is very good example that I have tried to give. So let's say there is one country, and inside country we have so many states. So to have routing between, let's say we are going from Bangalore city and we want to go to Surat or Gandhinagar. So what we will do is, if we are leaving from the Bangalore, we won't have routes to Gandhinagar inside this Karnataka, because the state or the country is so big. So in Karnataka, we'll have routes to, let's say we want to reach Gandhinagar, which is in Gujarat. So if we are leaving from the Bengaluru, we will have routes to Maharashtra, which has routes to Gujarat, and and when we enter into Gujarat, it will have routes to Gandhinagar. So that's how the concept of area is working. So consider this India country as a whole internet, and inside this internet we have so many areas. So every state can represent an area. So Gujarat area, Rajasthan area, Maharashtra area, and inside that area we have some routers. Let's say all the cities inside the Gujarat state. It can be all the cities inside every state. Usually it can be considered as a single router. So let's say Rajkot is in router, Surat is in router. So this is how OSPF is designed. So typically this is an example. So this is a typical example of multi-area OSPF configuration. So there we'll surely have one area called area 0, and all the other areas we will that all the areas will be connected to this area 0. So for example, here there is an area 1, area 2 and area 3, and some routers of area 1 are directly connected to routers on the area 0. So that is the usual configuration that we have. We'll explore this configuration in detail. Now these are some of the types of areas that we can find inside the OSPF. So let's start with the first area. So understanding this area types are usually critical for let's say if you want to configure OSPF, if you want to understand the configuration of OSPF, then these areas are important for you to understand. So the first area is the backbone area. As we have seen in the previous topology, so area 0, it is known as backbone area, and all the standard areas should be connected to this area. And the standard area, so the next definition for the standard area is here. So usually any other area than area 0, the backbone area, those all areas are considered as standard area, and it usually process and transmit all the LSA types, and it will prepare the LSDB. So that's the standard area. The backbone area also advertises all the LSAs and all the process all the LSAs. And but the only difference between backbone area and standard area is the backbone area is specifically area 0, and all the area other than 0, that is standard area. Now we have the third category, which is stubby area or stub area. So any standard area which blocks the external LSAs, let's say type 5 LSAs, which is external LSAs. So we use type 5 LSAs to advertise the routes that are learned via some another routing protocol, let's say RIP or some BGP. So that is if you want to advertise those routes, we use type 5 LSAs. And stub area which blocks this type 5 LSAs, so that is the standard area which blocks this type 5 LSAs, that is known as stub area. And if it blocks the type 5 LSAs, so then it uses the default route advertisement by the area border router. So what is default route advertisement is like if you want to reach to any routes that are not learned, so there will be a default route which can help you. So as we are not learning the external routes, so we would need to have something called default route. So default route is nothing but the area border router. So the router which is at the border of two areas, which can help us in this case, in this situation. That also we are going to see in the upcoming slide. So the next area is totally stubby area. So this area is not mostly not used by many of the what you can say customers or many of the it is not used in many of the configuration, but it's there, so you should be aware about this totally stubby area. So that's the another variant of stub area. And usually total stub area blocks all the types of LSAs, type 3, 4 and 5, and it relies on the default route advertisement by the ABR. So it has the routes that are learned from this area only, and it blocks all the other types of LSAs. It just relies on the default routes. So that's nothing but the totally stubby area. Now the last type that we have is NSSA, so which means not so stubby area. So this is also a standard area which allows the limited external routing, and it uses the type 7 LSAs, which is then converted to type 5 LSAs by the area border routers before it can enter the area 0. So the main difference between stub area and NSSA is like it blocks type 5 LSAs, whereas it allows type 5 LSAs, but the only part is it allows very limited type of external routes, and it uses the type 7. So type 7 means the router is in some another autonomous system, which means let's say we are a, let's say, service provider, and we have customer A and customer B. So both of those customers, we can consider those as different autonomous system. So if they want to exchange some routes, they will use type 7 routes, type 7 LSAs, not routes, type 7 LSAs, because they are learning routes of each other, and since they are not in the same what you can say autonomous system, that's why rather than using type 5, which is used to advertise external route but within the same organization or same autonomous system only, rather they are not in the same autonomous system, that's why they will use type 7 routes. More detailed explanation will be in the next slides. So this is the typical example of route for the OSPF area multi-area configuration. So in this diagram, now we have area 0, 1, 2 and 3. So in addition to the previous diagram, we have now backbone area, which is area 0, because just now we have seen the slide for the different types of areas, right? So we can differentiate between area types. So now this area 0, which is backbone area, and all the other areas are standard area. So that's the main point. Now let's look at the router types. So there are some different types of routers. So let's look at them one by one. So the first router type is internal router. So this is the type of router in which all the interfaces are in the same area. So it doesn't matter the area 0, 1 or 3 in which the router is, but just we need to see if all the interface of that router are in the same area. So that is considered as an internal area router. Now the second type is backbone router. So this router, so the main thing is we need to see if at least one of the interface of router is in the area 0. So then it can be considered as a backbone area router, backbone router. So the third part is third type of router is area border router, which is the type of router which connects area 0 to one or more non-backbone areas or the standard areas, which also summarizes the route between the area. So that is known as area border router, ABRs. Now the last thing is ASBR, which is autonomous system border router, which is really similar to area border router, but just the difference between ASBR and ABR is within the autonomous system. So let's say we are the same example that we have seen in the earlier. Let's say we are a service provider, we provide the internet service, and we have two customers. So both of those customers can be considered as in separate autonomous system. So inside, let's say customer 1, we have multiple areas, and the router which is connecting area 0 and another standard area, then it can be then that router can be considered as an ABR. But now let's say there is one router at the border of their entry point of the particular autonomous system or the organization that is connected to our router, or let's say the second customer is connected to our router, so that we can consider as an ASPR, because that is connected to our infrastructure and their infrastructure. So those both are different autonomous system. That's why this router can be considered as ASPR, which redistributes the external routes, let's say learned by BGP, static routes, or RIP into OSPF, and it also generates the type 5 or type 7 LSAs. So that is the main thing about ASPR, and these are the main router types in the OSPF. So now this was the previous example where we have identified the areas, backbone area and standard areas, right? So now as we have learned the router types, so we can identify the router types. So first we will start from the area 0. So as these both routers are in the area 0, we can consider them as backbone routers. So that's why I have written BR over here, over on top of these two routers. Now this router is connecting area 0 to area 1. So basically it has the link between the router which is in area 0. That's why it can be considered as the area border router. It can also be considered as a backbone router because it has at least one interface which is connected in area 0. But just for the significance of learning the different router types, I have written over here area border router. The same concept can be applied over here on the router which is in area 2. It is also area border router, and the same concept can be applied over here, which is the router inside the area 3. Now we have these three routers, this one in the area 3, this one in the area 1, and this one in the area 2. These routers have all the routes, all the interfaces which is connected into the same area. So this router, it has all the interfaces connected to area 3 only. This router, it has all the interfaces connected into area 1, and similar, this router, it has all the interfaces connected to area 2. That's why they can be considered as internal routers. So that's why I have written IR over here. So now look at the broader example of all the types of area types and all the different router types. So let's look at this example. Now this is the backbone area 0 obviously, and these two routers are backbone routers. That's why I have written BR over here. Now let's say these two routers which are in area 1, they belongs to some customer, let's say customer A. So this is the separate infrastructure which is connected to this service provider area 0 routers. This is another customer which is having area 2 and which is also connected to backbone router of, let's say this is a service provider network which is in area 0. This is the another customer which is also connected to backbone area which is service provider. So now let's say this area 3 is the standard area, this area 2 is stubby area, and this area 1 is NSSA. So now we can identify first of all the routers. So this router, it can be considered as ASPR because this area is area 1 is separate customer, so it will be separate autonomous system. So that's why this router which is connecting the area 1 to area 0, so that's why it can be considered as ASBR. It cannot be considered as backbone router, or it can be considered it can be considered as a backbone router because it has one interface connecting to area 0. But since it is connected to backbone area, but the backbone area is itself a service provider as the assumption that we have made, so it cannot be considered as a backbone area router. So the same concept applies to this area because this is also separate customers, so that's why ASBR is written over here, and the same concept applies over here. And for the internal routers, the same concept applies over here, here, and here because all the routers, it has all the interfaces connected to the same area. Now let's say this is the customer area which is having area 3, it requires that we will be having routes to all the we need routes to all the routers which are in backbone area. So they will have a area type which is standard area type. So it will receive type 3, type 4, type 5 and type 7, all the types of LSAs. It will transmit all the types of all the types of LSAs, and it will process all the types of LSAs. Now let's say this customer which is in area 1, they want that we do not want the external routes, we do not want the all types of routes, we just want the limited number of routes. Let's say we just want the routes learnt via or you can say those are having routes to area 2. So they will keep this area NSSA, and they will receive type 7 and type 5 LSAs. They will transmit type 7 LSAs, but the type 7 LSAs will be converted to type 5 by this ASBR before it can be transmitted to area 0. So that's how they will process. Now we have this stubby area. So this customer wants that we do not want to learn any type of external routes. So they will make the stubby area, the area 2 as in stubby area. Now they won't receive any type 5 or type 7 LSAs. So this is just an example. You might have a question that if this guys want to have routes to this guys, the customer, but as they are not processing the external routes, so they won't receive any external routes learned from this customer. So that is just for an example. That's not the case that you might have in real life. So this is the broad example of OSPF area and router types. So in addition to all those router types, we have two more router types, which is DR and BDR, which is designated router and backup designated router. So what it does is, let's say we have a single area or multi-area OSPF topology, and let's say this is how the topology is connected. All the routers are not connected inside the mesh kind of thingy. So this is the kind of configuration for OSPF network. Now let's say one of the routes gets failed, or we have new routes learned via any one of these router. Now it will advertise to the neighbor routers, and the neighbor routers will take the copy and forward again to their neighbors, and it will be forwarded to this neighbor again. I mean, let's say this router over here, it advertises the let's say routing table, the new entry. So it will take a copy and it will again broadcast the routing entry towards this router again, and this will process the routing table, the information inside the LS link state update, and it will again broadcast the what you can say routing table to their neighbors. So that's how this network will be congested with the LSUs and frequent what you can say SPF algorithm run. So to avoid that, we have something called DR and BDR. Now what it does is, so whenever we run the OSPF, it will elect the DR and BDR itself. And the working of DR and BDR is simple. So whenever these routers, they have something to advertise, they won't directly advertise to all the routers. So they will advertise the information first to the DR, and then DR will advertise the information to all the routers in the area. So that is the working of DR. So designated router, it just has one purpose, to advertise the routes learned via any of the router, so that we have just one point of contact if all of these router want to advertise or want to get some information from the network topology. And BDR, backup designated router, so in case let's say DR is failed, so BDR will take the place of DR, and they will have some syncing mechanism between them to have the same LSDB between both of this. So that's the DR and BDR. So now let's look at the OSPF configuration, or not the configuration, just the operations. So let's assume that we have OSPF configuration successful between these two routers, router 1 and router 2, and both have interface Ethernet 1 connected to each other. So the first thing after we successfully configure the OSPF between these two is what will happen is, the first thing will happen is neighbor discovery. In this phase, each router will send the OSPF hello packet, and hello packet, as we have seen earlier, this is the kind of hello packet. It will have the information regarding the router ID. So the router ID of router 1 will be sent on this packet, router ID of router 2 will be sent on this packet. Other than that, it will also have the information regarding the area ID, authentication, the hello interval, dead interval, backup designated router, address of that, and all of these information will be included inside the hello packet. So both will exchange the hello packet, and at the end of this hello packet exchange, we will have something called the OSPF neighbor table. So at the end of this space, if we enter the show IP OSPF neighbor command, so we will have this kind of table which will have the router ID and the port mapping. So router 2 will be mapped to Ethernet 1 port on this router. So through this command we can see what are the neighbors that the router 1 has. Now the second step that will happen is routes discovery. So in this phase, both the routers will start to advertise the LSUs, and LSUs will have the information regarding the routes in the form of LSAs. And at the end of this phase, we can enter the show IP OSPF database command, which will have the database of particular device. It will have information regarding what are the LSA types learned via which router, and the LSA which contains the what are the types of routes. So this table we can see at the end of this phase. Now the third and last phase is to run the SPF algorithm, and the SPF algorithm, it will take the best path from the LSDB. So all the LSDBs that it has got. Now the cost calculation is very important. So we can calculate the cost, which is equals to reference bandwidth, which is 10 raised to 8 divided by the interface bandwidth. So let's say if the interface bandwidth is 10 Mbps, which is equal to 10 raised to 7. So the cost will be 10, because 10 raised to 8 divided by 10 raised to 7 is 10. Now if let's say the bandwidth for this interface is 100 Mbps, so it will be 10 raised to 8, because 10 raised to 100 into 10 raised to 6, which means 10 raised to 8. So if we put 10 raised to 8 divided by interface bandwidth, which is equals to 10 raised to 8, we will get the cost 1. And if any of the bandwidth which is greater than or equal to 100 Mbps, the cost will be 1. And remember, we cannot put the cost in decimal point, so it will be integer always. So that's why for any bandwidth which is greater than or equal to 100 Mbps, the cost will be 1. So that's how we run the SPF algorithm. Also, one thing you can note is we can change the cost of particular interface by using this command under the interface configuration mode, which is IP OSPF cost, and inside over here we can put the cost that we want. So that's how the OSPF operation is working behind the scenes. And thank you for listening till now. So in this video we have seen the OSPF area types, OSPF router types, and how OSPF communication is working behind the scenes. I hope you have got the broader idea of how OSPF is working in the background. We will have a demo on CPT, Cisco Packet Tracer, regarding how we can configure the OSPF single area and multi-area in the upcoming videos. So behold and subscribe for updates regarding those videos. And that's it for this video. We'll meet in the next video. Till then, keep learning and keep exploring.